All right, well, here it is. There's our vertex form. Our vertex is up here. We got H and K. We've got X and Y. We're going to drop those in. Solve for A. All right, is that what we get for A? Negative 0.04. Okay. So the equation, we'll get Y equals negative 0.04 times X minus 30 squared plus 50. So that's our equation. So perform attempts a long distance trick shot at a basket attached to a building 50 feet away. Okay. Write an equation of the parabola. What is the height of the goal if the player hits the rim? Oh, there we go. Let's see. Anybody have it? Height of the goal is what? Who's got it? It's this point right here, by the way. We know the X value. What's the Y value? 34. There you go. Height of the goal is 34 feet. Nice. We got our equation. We used our equation, plugged in 50 for it. For X, got a Y value of 34. So height of the goal, 34 feet. So basically exactly what we did yesterday. Next question. Also what we did yesterday using the other form that we went with, which is the intercept form. So let's see, a kingfisher bird is perched on a tree limb 15 feet above the riverbank, right here. If it dives into the river, following a parabolic path, try to catch a fish. It splashes into the water 4 feet from the riverbank. So here's the riverbank, 4 feet away from the riverbank, and returns to the surface 9 feet from the bank. Write a quadratic equation that models the bird's path. Okay. So let's see, we've got X and Y, we have P, we have Q, and we're going with intercept form. So once again, this is Y equals A, we got X minus P times X minus Q. So that'll be 15 equals A times 0 minus 4 times 0 minus 9. This would be 15 equals 36A. Definitely go with a fraction for your value of A on this one. Although, one second here. Ooh. Yeah, that was good. So, somebody have it? 5/12, good. 15 divided by 36 does not make a nice decimal, and 15/36 can be reduced. And if you want to, on your calculator, you can change that to a fraction by hitting the button that says math. And then you can change whatever your answer is into a fraction by just using option number 1. And there it is, 5/12. So a equals 5/12. So we're going to end up with y equals 5/12 times x minus 4 times x minus 9. And it says that if a fish is 2.5 feet under the water, could the bird catch it? Two and a half feet would be the height, right? Okay. So what is if we wanted to figure out as deep as the bird went, what point would we be looking for? What was it? The vertex, yeah. Because the bottom of the vertex is as deep as the bird went underwater. So if this number is less than negative 2.5, then we're good. If it's not, then the bird couldn't have caught it because it didn't go deep enough. So let's figure out the vertex. Start by adding the two values of p and q together. So x is going to equal 4 plus 9 divided by 2. 4 plus 9 is 13. 13 divided by 2 would be 6.5. So then take 6.5, plug it back in. I don't know why I wrote 5/2. 5/12. There we go. 5/12. All right, so we have ourselves, let's see, fraction 5/12 multiplied by 6.5 minus 4, close that up, and then 6.5 minus 9, close that up. And that gives us an x value of about negative 2.6 feet. So the fish was 2.5 feet underwater. The maximum depth of the bird was 2.6 feet. So that would be the y value. Sorry. Because we had x, 6.5. So was the bird able to catch the fish? Yeah. Let's see. The bird could catch the fish because it dove to a depth of 2.6 feet under water. Then to justify the answer, so we'll justify it very quickly. So the bird could catch the fish because it dove to a depth of 2.6 feet underwater. Cool. All right, now, this last one, something that we did, I think last week actually, using the quadratic formula. And we're actually going to go with a y value of 0 instead of 25 or negative 25. So it says use the quadratic formula to find the value of x for the given values of y. Round your answers to the nearest hundredth when necessary, so 2 decimal places. We have our equation here, negative 3x squared plus 5x minus 8 when y equals negative 25. Cross off negative 25, put in 0 instead. So let's get our values of a, b, and c real quick, and then we're going to drop them in here and then solve both of our very quick equations and get our answers. So what does a equal? Negative 3. What does b equal? 5. And what does c equal? Negative 8. You might have noticed that we're using all 3 forms of our quadratics on this warm-up, right? We got vertex form, intercept form, now standard form. Okay, so for our equation, we're going to plug into the formula. Y is equal to the opposite of b, so negative 5 plus or minus the square root of b squared, which would be 5 squared, which is just 25. So I'm going to write 25. Minus 4 times a, which is negative 3 times c, which is negative 8, all divided by 2 times a. A is negative 3, so I'm just going to say negative 6. And we're going to get 2 answers here. Probably. All right. I say probably because we don't always get 2 answers. Sometimes you get 1, sometimes you don't get any, depending on what we end up with. But let's go ahead and get our fraction going here. So open up your fraction on your calculator. start with -5. We'll do the addition version first. So plus square root, and then 25 minus 4 with a -3 and then a -8. And that's all going to go over -6. Ooh, error, unreal answer. Oh, no. Did we do something wrong with the question? What do we think? I'm going to double check. Make sure that none of the other numbers got changed because we changed -25 to 0. Unreal answer is not necessarily a bad thing. It just is an option. I just want to make sure that's the way it's supposed to be. Bear with me for a second. Yeah, that's correct. So, does anybody know why we get this? By the way, this is the right answer. It says error. Unreal answer is what it said for us. Does anybody know what we should write then? No solution. And in fact, we're going to be a little more detailed because starting in the next unit, we're going to see that we actually could answer this question. We're not going to be able to answer it in this unit, but we actually can answer this question because it says, it doesn't say there aren't any answers at all, does it? It says there's no, what kind of answers? There's no real answers. So there are other answers than real answers. We will learn about that next unit though. So there's your teaser for chapter 3. So we're going to say no real solutions. Does anybody know what they would be called if they weren't real? What's that? They're not undefined. Any other guesses on that? I'll let you know before we. Imaginary? Yeah, they're imaginary, which is an actual thing. There are things in math called imaginary numbers. They're not real, they're imaginary, but they are able to be worked with, and they're very strange. But they are useful. They are actually useful in the real world in terms of like electricity and things like that. So you can thank people who figured out imaginary numbers because we have electricity. So, all right, turn the page. By the way, the reason why this ended up being the answer, the reason why this ended up being the answer is because everything under the square root ended up being a negative number. And technically, there are no real answers if you have a negative under your square root because you can't multiply a number by itself and end up with a negative number. So that's why we got no real solutions here. Okay. So today we get to work with our calculators. So we're going to determine if the data are linear, quadratic, or neither, and then write an equation that fits the data. So the way that we can test to see if sets of data happen to be linear or quadratic or neither is by looking at the differences between the x's and the y's. So first of all, do we have consistent increases along our x-axis, along our values of x? Yeah? What are they going up by each time? 3. So every single increase here is +3. It matters that we are increasing consistently along the x-axis because if we're not, then it doesn't really matter if the y's are increasing or decreasing consistently because these ones wouldn't be consistent either. So we have to make sure we're going along like set intervals, right? In order to actually get the information that we need. Across the y values though, what's happening from 36 to 30? Decrease of 6, okay. And then 30 to 24? Decrease of 6, 24 to 18, decrease of 6, 18 to 12, minus 6, and then 12 to 6, minus 6. Okay, so these right here are what are known as first differences. The differences between the y values are consistent. So we're going to say first differences are congruent. Therefore, linear. If your first differences are all the same, that is a linear relationship. Every time x increases by 3, y decreases by 6. Which is basically a slope, right? Change in y over change in x. So the change in y is -6 over the change in x is 3. So we can actually just say m is equal to the change in y, -6, over the change in x, which is 3. What's -6 divided by 3? -2. So the slope is -2. And the y-intercept is whenever x is equal to 0, which is here. So the y-intercept is 36. So b equals 36, which means we have y equals -2x plus 36. So we got linear, and we have an equation of y equals -2x plus 36. All right, now we're going to go ahead and start using our calculators on this one, because this time every single x value is going up by 1. I think that's obvious enough. We don't need to write +1. What's going on with our y values here? 24 to 16 would be what? A decrease of 8. Okay. How about 416 down to 376? What is it? Decrease of 40. Okay. So -40. So right now we can tell right away this is not linear. What about a decrease from 376 down to 304? -72. How about 304 down to 200? -104. How about 200 down to 64? 136? Yeah, -136. Okay. So our first differences are not consistent. What about our second differences, though? What if we find the differences between the original differences? What about -8 down to -40? -32. So that's a decrease of 32 from -8 down to -40 is a decrease of 32. How about 40 to 72 in terms of negatives? Decrease of what? 32 again, right? So -32. 72 to 104, what do we think? Probably -32, okay? And then 104 down to 136 negatives. That would be also -32. So this time, the second differences are congruent. So second differences are congruent. Therefore, quadratic. So this is a quadratic relationship. So first difference is linear, second difference is quadratic. If there were third differences, by the way, that would be the next level, which would be cubic, but we're not going to run into that, at least not right now. But what I'd like to do is spend some time here figuring out what the equation actually is for these points, because we're going to have some other questions that are going to be dealing with that as well. So let's go ahead and get into our table of values on our calculator. So remember, that is where you click on stat. You get your calculators open, hit stat, and then it's the first option under stat, which is edit. So hit enter after that. If you have any information on your lists, go all the way up to the top of L1, hit clear, and then hit enter. And then go all the way up to L2, where it highlights L2 itself, hit clear, and then enter, and that should get rid of all the numbers in those lists, if you have numbers in your lists. All right, then we're going to type in the numbers that are in L1 and L2. So L1, those are x values, 1 through 6. So 1, 2, 3, 4, 5, 6. L2 are going to be all the y values. So we're going to have, starting with 424, and then 416, 376, 304, 200, and 64. So far, this is exactly the same as what we did to figure out the linear equations. In fact, calculating the quadratic equation is also going to be incredibly similar, because once you have this information on here, just like we did with linear, you're going to go back to stat, over to calc. But this time, instead of going to linreg, option number 4 for linear regression, we don't want linear, we want quadratic. So that would be the next option, quadratic regression. So instead of option 4, you're going to go to option 5. And then you're going to hit enter. And it's going to be the same as what we did with linear, except it's going to calculate the quadratic equation instead of the linear equation. And there it is. Values of A, B, and C. So this is going to lend to standard form because those are our values that we need. So when we write our equation, we're going to say y equals negative 16x squared plus 40x plus 400. Because A, B, and C. That was y equals ax squared plus bx plus c. And it just tells you right here the values of A, B, and C. So you just plug those in for A, B, and C, and that's your quadratic equation in standard form. That's basically what we're going to be doing today, by the way. So almost exactly the same as figuring out linear regression, except we're going to go with quadratic instead. All right. What if we look at the possibilities for problem C? So these are all going up by 1 again. Our first difference is, let's see, 5 to 15 is an increase of 10, 15 to 45, that's an increase of 30, so plus 30. 45 to 135, what's that an increase of? 90, so plus 90. 135 to 405. 270 plus 270, and then 405 to 1215. $810, so plus 810. All right, so first difference is certainly not linear. Second difference is 10 to 30 is plus 20. 30 to 90 is plus 60. So we're not quadratic either. 90 to 270. 180, yeah. 270 to 810. What is it? 550, okay. So not quadratic either. And we're just going to stop there because even if you go to the third differences, they're not even the same either. So this is going to be, we're going to say neither because right now we're testing between linear or quadratic. It even said so at the top here. If the data are linear, quadratic, or neither. So this one, definitely neither because the first differences are not the same and neither the second differences. So we're just going to stop after that. And we'll say neither for that. If it's neither, it's kind of convenient because you don't have to do any calculations after that. You're just done. You don't even have to write an equation. You just leave it. All right. Questions here before we move on? Cool. Flip it over. So our last few problems here very quickly. We're going to type in our information. We're going to figure out the parabola. So this is telling you it is quadratic. So NASA can create a weightless environment by flying an airplane in parabolic path. So basically, if you've ever heard of like weightless training for flights, they basically take these jumbo jets and they do this with it, which sounds terrible. But basically when they, in the process from increasing to decreasing, that little time frame there, there's actually a little bit of weightlessness that you can experience when you go from that increasing to decreasing over that inverted parabola. The table shows the height, h in feet, of a plane in t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. So basically, you're looking for a vertex. So we need to get the equation first, and then we're going to figure out where the vertex is based on that equation. So we're going to type in our information once again. So we're going to go back to stat, edit, and we're going to have 10, 15. By the way, you don't have to clear it necessarily. You can just type over what's already there. 20, 25, 30, 35, and 40. And then we're going to have our other values over here, starting with 26,900, and then 29,025, 30,600, 29025. Okay. 31,625. 32,100, 32,025, and 31,400. Once you have those in there, by the way, when the more numbers you have or the larger the digits are, larger the numbers are, double check them just to make sure they're correct on your calculator. Because if they're not, you won't get the right answer no matter what you do. So back to stat, over to calc, down to option 5. Calculate your quadratic regression. Here's our parabola in standard form. So we're going to get y equals negative 11x squared plus 700x plus 21,000. Anybody not getting that on their quadratic regression? These should be nice whole numbers. All right. Once we have that, we have to figure out the height at which the weightlessness is occurring, which would be the top of the parabola, which in the case of this problem would be the vertex. So actually, you know what? We don't need to figure out the vertex because it gives us an x value. Never mind. It tells us the time right here, 20.8. So we don't even need to do that. We just need to take that and plug that in for x. Let's do that instead. So that'll be y equals negative 11 times 20.8 squared plus 700 times 20.8 plus 21,000. It's easier than I was making it. All right, so negative 11, 20.8, close it up, square it, plus 700, 20.8, and then plus 21,000. All right. Approximate the height at which this occurs. So weightlessness. I don't know if I've ever actually written that word before. Weightlessness. Okay. Weightlessness occurs at what height? What's that? I got a different number. Yeah, I got 30,800 feet. 30,800.96 feet is what I ended up with, which is about 30,801 feet. Yeah. Okay. At about 30,801 feet. Okay, there we go. So there's that. I'm just going to talk about B. I'm going to not actually not go through the actual numbers of it, but any questions on part A here? Basically, as long as you remember how to use your calculator. By the way, you can do all this on Desmos as well. There is a quadratic regression on Desmos, similar to the linear regression. I will find a video. I will post that to Google Classroom as well in terms of how to do that on Desmos, because I think most people will be doing that at home. So, all right. Next one. The table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed in miles per gallon. So if you're optimizing miles per gallon, what would that be in terms of, like, would that be most or least for miles per gallon? Most, which would be the vertex. So this one we're using, figuring out the vertex. So that's what you'll have to do on this one. We're not going to do it, but you type that in, you get your equation, you write your equation, and then you would find the vertex of standard form. So that would be the x equals opposite b over 2a, figure out the value of x, plug it in, figure out y. That's what would happen on this one. All right, turn the page, last problem. Got a few things to do here. The table shows a university's budget in millions of dollars over a 10-year period where x equals 0 represents the first year in the 10-year period. So 9 would represent the 10th year in the 10-year period. 0 is the first year. Use a graphing calculator to create a scatter plot, which better represents the data, a line or a parabola, and then explain. So let's get a scatter plot. This is the first time we've done a scatter plot. So we're going to do the same thing we did, though, to start off with. Go back to your L1, L2, type in the values. So we're going to have 0 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So 10 numbers on each list. L2, we got 65, and then 32, 22, 40, 65, 72, 114, 128, 40, and 150. All right. Now, these will neither be perfectly linear nor perfectly quadratic. So that's why we're going to actually look at the scatter plot to decide if it should be about linear or about quadratic. So once you have this in here, what we need to do is we are going to go to our stat plot menu. So stat plot is the blue writing above the y equals. So you're going to hit second and then the y equals button. And that will take you to your stat plot menu. And once you get here, just choose plot number 1, hit enter. And we want to turn that on. And then the type that we want is this one here, just the dots, that's a scatter plot. X list is L1, that's what we want. Y list is L2. The markers and the colors, however you want to do that. Yeah. Second, and then the Y equals button. And then just choose plot number 1, hit enter for that, and make sure you turn that on. All right, now in order to see the scatter plot, we're going to need to adjust our window of view to accommodate for these numbers over here. So once you've got your stat plot turned on, click on the button that says window. It's right next to the Y equals. Click on window. And then we're just going to adjust the window for the values that are over here. So our minimum X value is going to be 0. Our maximum X value will be 9. Or if you want to do 10, that's fine too. Doesn't really matter. And then the maximum is 10, scale 1, that's fine. The minimum Y value, the smallest Y value we have on our list is what? 22, so let's do 20. What's the maximum? 150, so let's just do 155. Get a little bit of wiggle room on either side of it. And then the scale, I don't know, maybe 10, 15, not 1. That wouldn't be very good. That would be a little bit too condensed. But if we go by 10s, that's fine. And then hit the graph button on the upper right, and you should see all of your points right there. And next to mine, I actually have my L1 and L2. And if you notice, these first 3 points are moving in a downward direction, then they go back out this way. So would that be most like a linear or a quadratic? That'd be more quadratic than anything else, right? Okay. So quadratic, so we're going to say quadratic. Oops, quadratic. Because it's, let's say, roughly a parabola. It's not a perfect parabola, but it generally has that kind of shape to it. So it says use the regression feature on your calculator to find the model that best fits the data. Okay, so once you have that, you're going to make your quadratic regression. We still have like 10 minutes left. We're good. So go to stat.
Do you still need to pick up your student ID card? Please see Andrea in the Career Center for your ID card or to buy a sticker to make your ID into an ASB card. You can go to the Career Center during passing times, at lunch, or before or after school to get your ID. And the Girls Who Code group starts tomorrow, the 28th, in room 215 at lunch. Snacks will be provided. The Art Club is hosting its Artsy Fartsy Friday, this Friday the 29th at lunch in room 310. Everyone's welcome. We're also going to be discussing art club opportunities for this year. That's all the announcements. Here's your joke of the day. Did you hear about the fire at the shoe factory? Unfortunately, many souls were lost. Have a great day.
Sad. Okay, we still have about 7 or 8 minutes, so we definitely have time to do this. All right, so here's our equation. And then let's go ahead and graph that as well. So what you can do on your calculator, once you have your quadratic regression, write your equation out, go back to the Y equals menu, just the Y equals, not the stat plot. Clear out any equations that are there already. And then we can actually import the function that your calculator just came up with. So everybody go to your Y equals menu, clear out Y1. And then to import that function, you're going to click the button that says vars right here, right underneath the down arrow. So hit vars, go down to number 5, statistics on the vars menu, hit 5 or go down and select 5. And then scroll over to EQ. And then you're going to choose this first one, reg EQ. So this is the stored equation that's on your calculator. And you're going to hit enter. And right there, it'll import it right into that Y1. And then if you go back to your graph, it should model that with a rough estimation through the points that are there, which is kind of cool. So what it wants us to do next, use part 2 to predict when the budget of the university is $500 million, which would be a Y value of what? The Y values are in millions, so the Y value would be what? 500, yeah. So we're gonna say 500 equals 1.49x squared plus 0.51x plus 39.98, or we could as well, if we want to, just have our calculator tell us. That might be the best way to do this right now. Go to second, hit second, go to table, and we want the actual table though. Hang on real quick. Let's see, stat plot. I'm going to turn that off real quick. I'm just going to go back to my table. Okay, and we want a Y value of 500. So it's going to be somewhere in between 17 and 18 years. 479, 492. Okay, so by the way, if we were to do this, we would have to use the quadratic formula again, which is again why we actually used what was on the front here. Because we need to get this equal to 0. I'm just going to show you how to set this up. Subtract 500 from both sides to get this equal to 0, because in order to use the quadratic formula, you have to have it equal to 0. So it'll be 39.98 minus 500. So you're going to get 0 equals 1.49x squared plus 0.51x minus 460.02. From there, you would use your quadratic formula, and you would only take the positive answer, because the negative answer would be like back in time, and it wants to know in the future. So that's how you'd end up doing that quadratic formula after this. So your assignment is posted on your sheet. I will get the actual assignment posted in Google Classroom later, along with directions on how to use Desmos to get your quadratic regression.